I wanted to show you guys what I was doing with this copper pipe heater. I got this new power supply. I have my power supply here so I can measure voltage in the amps. And then I'll be measuring the RPMs to see how fast it's spinning. One of those that have been following me suggested I put some holes in here to help dissipate the heat. And so then I also put this fan on, and what I got to do now is, this is not level, so it kind of wobbles. This is my rotor, and right now I just have the 3 magnets on them. They're all facing north, and I have more magnets I'll put on here and get it facing south. And so I'll do some test loads with that and show you the different amp draws. And I did a little bit of preliminary testing with the speed of this motor, and I found that it'll run on less than an amp at 12 volts. But boy, once you put that magnet in there and it gets underneath the load, it really jumps up there. So anyway, this will be how it's going to be set up with the fan on there, and it'll blow heat out. And one of the guys suggested that this is a very, very poor heater, and he's absolutely right. It is a poor heater. It's for poor people. This thing will get up to 300 degrees, and if you're living in an RV or if you're homeless living out of your car, this thing will run on 50 watts to heat up your car instead of having to start your car every 20 minutes. I mean, this is a perfect solution for people like that. It's not going to get hot enough to where it's going to catch anything on fire, and they're not going to get gassed, carbon monoxide poisoning from running some other type of a heating system. So anyway, I just want to let you guys know what I've been working on and showing you what the progress is going to be showing here in a little while. On the TV screen you can see right here, this is a Keppe motor. I built one of those, must have been 3 years ago. I started messing around with the Keppe motor. I took the windings off of this. But the Keppe motor is designed to run on 1/10 of the electricity of a normal fan. And because there's no iron involved, there's no lens effects, which means it stops and retards it causes the motor to use a lot more energy. So whenever the lens effect is removed, then you get to have a more efficient motor. Well, they got it hooked up to a water pump, runs off a small solar panel, and they're actually claiming at their website that Keppe motor that they have set up right now, I think they're using 6 different magnets and 6 coils, and they're getting 137% efficiency, which means it puts out more energy than it consumes. Because as you run these motors, when you turn the coil on and off, that back EMF, it spikes really high. It takes 90 volts to light this neon bulb. I think some of them are rated around 60. This one also comes with the resistor in there. I started making this pulse motor, and I run through so many transistors and so many, I burned out so much stuff that I found when I made mine, I made it a metal contactor, and then I found out that if I hook a capacitor up to absorb that back spike, the spark in the contactor goes away, which is pretty cool, because that means I can store that energy in a capacitor and then send it back to the source and power. And so anyway, I also have a thermostat controller. I got this from Banggood, so it's going to be able to control the temperature of the copper pipe once I get it running, and that part's kind of cool. And but if you guys want to go and check something out, check out that Keppe motor. They're in Sao Paulo, Brazil. They've been working on it for 10 years. It's kind of similar to the Bedini window motor and lid motor, and a few other guys been making different things, but I've never seen. Russ Grease did a pulse motor build off a few years ago, and but I've never seen anybody actually apply it to some kind of work. And yeah, it's fine to get something to run off a small capacitor for a long time, but hey, I want to see some work. I want to generate some heat like this heater, and I want to generate some heat. Now I'm going to tell you guys some of the other things that I learned when I was in conservation working for PG&E back in California about 30 years ago. And so I'm going to show you guys what I learned way back then and why I'm approaching it this way, because you know, if I can get this thing to run on 10 watts, 20 watts, and it'll heat up the inside of a van or a small RV, I mean, it's going to be fascinating. And then I also have some other things I'm going to show you guys later on how this is all going to be encased, so it's not going to tip over and catch on fire or do anything, and it'll, yeah, that's going to be really cool. I got this fan put on here, and I 3D printed a fan, but I go, you know what, 300 degrees, that might not last very long. So anyway, I'm playing with the idea of getting this new copper pipe magnetic heater going, and I've got some controllers. I've got a over here I got a motor controller for speed, but I can control the speed right now by my power supply. So anyway, I wanted to do an update and tell you guys what I was working on and what I got going. I got some new equipment now that I can play with and take voltage readings and determine how efficient this thing is going to run. And it's a simple little design, anybody can make it. But if I can do some things that'll make it use a lot less energy, you know, and measure the temperature and see what the thing can produce, then hey, we might be onto something that might be useful for poor people. Very, very poor heater, the guy said on one of the comments. But anyway, this is what I'm working on. I'm going to try to get this. This has a little bit of a wobble to it, so I've got to get that leveled out. I sure wished I had a little mini lathe, metal lathe, but I have to kind of do this and chop it up and try to get it level and balanced, and it takes me a little while to do what I need to get done. But anyway, that's the latest on what I'm doing with this copper pipe magnetic heater. And I want to thank you guys for tuning in and watching. I finally got over 100 subscribers, and it's been over 9,000 views, and this has been about a year ago I did this, and so I figured I better get started updating you guys. So hey, thanks for watching, and I'll try to get something posted here again within the next week or so, and keep you guys posted on what the testing is going to prove, the amp draw and the RPM and the temperature all turns out. Okay, well, thanks for watching.